All right, good afternoon, everybody, and welcome to Datron webinar number 1. This is all about the single flute end mill. We're going to be going for about a half hour, 45 minutes here. We're going to go through some introductions, some concept and design. We're going to talk about the materials you can cut, the machines you can use them with, and of course the applications that you can use them in. First, to get started right off, we're going to go through some introductions, and I would like to introduce everybody to my brother and co-host, Dan DeMazier. Dan, say hi.
Hey, everybody. So I'm an application project manager over here at Datron. That means I get to work with sales and marketing and customers doing all sorts of cool projects, playing with different materials, different tools, automation, stuff like that. Here's a whole bunch of factoids about me. But most importantly, follow me on Instagram. You get to see all the cool stuff I work on a daily basis.
There you go. Moving on to myself, that's me, that goofy-looking character. I'm Neil DeMazier. I'm the regional sales manager for the Northeast United States. So New York and New Jersey and all points north. I'm your guy for Datron cutting tools, Datron machines, or work holding. I've been here since 2011, and you can find me on Instagram at HSC Pro. So a little bit on the company history, just to give you guys an idea of where we're coming from here. Datron was actually founded in 1969 as an electronics company. The name actually comes from Darmstadt Electronics. After a little while of doing some engineering and electronic stuff, they developed their own CNC milling machine for internal use for PCB depaneling and routing. And soon after that, switched their business model to produce high RPM, high performance gantry style milling machines. That change necessitated designing and developing and producing their own line of solid carbide cutting tools, which really, the focus of which was on the single flute end mill. And ever since that time, we've been working to perfect the single flute end mill design. Switching over to Datron USA, this was started in Mississauga, Ontario by actually the very first Datron machine user in North America, a gentleman by the name of Bill King, who is our president today. Relocated it to the United States back in 2000, after which we expanded in 2004, 2013, and 2015. And fast forward to today, we have offices just outside of San Francisco and just outside of Boston, where we stock the cutting tools and, of course, the Datron machines as well. You can find us on Instagram at Datron CNC or Facebook, likewise, Datron CNC. In terms of presentation goals, Dan, why don't you tell us what we're here to do today?
Yeah, absolutely. So we want to sort of demystify, take the stigma out of using single flute end mills. They're so commonly referred to as just a tool for routers, but they're useful for a lot more than that. So we want to touch on some of the valuable strategies and methods for using them, when they're applicable, what materials it makes sense to use them with, what machines, and sort of just educate everyone on how you can, make them a tool in your toolbox to best utilize.
But more importantly, we're gonna focus on strategies that can be used for both traditional VMCs, vertical milling centers, horizontals. We're gonna focus on areas that you can use these tools not just in Datron machines, not just in high-speed cutting machines, but in benchtop machines, typical VMCs that you might use, every day at a typical machine
Good
shop.
Applications everywhere for them.
Yep. So without any further ado, we're going to get into the monocle of milling, the unicycle of cutting tools, the single flute end mill.
The unicorn?
The narwhal?
The narwhal. The narwhal of cutting tools.
There we go. Yes.
Okay.
So let's start off with just some intrinsic advantages of the design of this tool. As Dan said, historically it's regarded as a router bit. And it kind of gets pigeonholed into saying, hey, it's good for CNC routing of wood or plastics. But what you're going to find today is that it's applicable to many, many more materials than just wood or plastics. It works great in those, but it's applicable to many more materials.
Yeah. So because it has that one single flute, it has a huge chip channel. And chip channel size is really what holds a lot of tools back. It's not their core strength. It is how much room they have to channel that chip up and out, because otherwise you're going to end up double cutting them, and that's really what causes a lot of premature tool failure. So with one big flute, we're able to take a much larger than normal chip load, which you'll be able to see in a few minutes, and evacuate it out at a high velocity. So that's really one of the keys of why single flutes are really a tremendous tool to have in your arsenal.
And second of which, we're going to talk a little bit about how these tools are noted for being remarkably sharp. And we've speculated a little bit as to why this could be. In our best guess, of course, we're not privy to the secret sauce of how Datron Germany makes these tools, but We like to think that that one large chip channel allows for greater clearance of that grinding wheel in the CNC grinding machine that is used to make these tools. It allows that wheel to get in at a better angle to produce a sharper cutting edge. And that sharper edge, of course, is better for chip formation, yes, but it also improves the surface finish on your milled wall. It improves many aspects of the cutting tool performance.
Right.
And those two things together, we really can't overstate how important those are. The ability to create a chip very, very well, create a bigger chip than you normally be able to in a 2-flute or a 3-flute, and evacuate it out at regular RPM or high RPM is really what gives these tools their power.
Yep, absolutely. All right, moving on from there. Touch on some of the advancements that Datron has integrated over the years. Since they've been using single flutes for so long, we'll touch on one of the most recent changes, which was they added a wiper flat to the tip of the tool. Now, what a wiper flat does is instead of the tool coming to, we're referring to square cutting end mills, instead of it coming to a sharp point at the tip, which you can find, especially with sort of roughing, things like that, it's going to leave some circular tool paths on the floor that might be a little unsightly. If you're looking for a really good RA value, high quality floor finish, you integrate a wiper flat. What that looks like is this. So props to Eddie Kramer, who really was like, I understand what a wiper flat is, but I don't know what it looks like. So here's a perfect side-by-side. On the right-hand side, we have one of our standard, or actually a specially balanced single flute, Datron single flute. On the left, we have a 4-in-1, which has a wiper flat integrated at the tip. So you can see there how instead of it coming to that sharp 45-degree point at the tip, they have a smaller 45 and then a large, well, comparatively large flat surface there. So that improves floor finish quality without applying too much downward cutting pressure, too much pressure on the floor of the material, which can be problematic for thin materials.
Yeah, obviously a very small feature. We had to get it under the microscope just to be able to see it, but makes a big, big impact on the quality of the floor finish. And really, all of these advancements that we're talking about, we've developed fixes for these because they address kind of deficiencies in the standard single flute cutting tool. One of those deficiencies that is really inherent in the design of the tool is the fact that it is somewhat imbalanced, right? You have this one large flute on one side, nothing on the other side, so that develops a weight imbalance that isn't so much of a problem at small cutting diameters, but it becomes an increasingly large problem as the cutting diameter becomes larger.
Right.
So what we do to address that is if you look here, you see there's material removed on the tool shank opposite from the cutting flute, right? So opposite the chip channel is this material removed. And what that does is it counterbalances that chip channel so that now you can go much higher in an RPM range, even with a large diameter cutting tool. Right. And you'll see a little bit later the impact that can have on material removal rate. But that is something that is unique to Datron.
What it also does, worth noting, is that besides the fact that it balances it so you can run it at a higher RPM, that extends your spindle life, that extends your tool life, as well as gives you a better surface finish because there's less vibration going into the material. Then from there, polish flute and cutting edge. This started with a line of single flutes that we sell that are made for acrylics, plastics, polycarbonate, things like that, for getting a really high quality wall finish. And the thought behind it is because they polish the flute and the chip channel, it gives very low frictional losses. It shears the material very cleanly. Now, they were able to apply some of those same principles to our 4-in-1 lineup so that we have less of those frictional losses, right? So we draw less power from our spindle in order to cut the material. We get better chip formation, and we have better chip evacuation properties, even on top of how good it is with a single flute normally, because it allows the chip on its way out to just glide on up and out at a high rate of speed.
Exactly, right. And we're talking about polishing the interior of the cutting flute here, and on the opposite side over here, the leading edge of the actual cutting edge itself. So just to tie in where these features come into our product line, we just wanted to touch on that real quickly. As you can see over here on the side, we have 3 product lines. The standard is, of course, a single flute, but it is not balanced, does not have the wiper flat. It is available in a toric cut, which is basically a relieved shank. It gives you a little bit more depth, a little bit more reachability. These tools are great for roughing. They're good for wall finish, good for floor finish, kind of a good, decent all-around single flute. Moving on to the balanced line, the major difference, as you might guess, is that these single flutes are balanced. So that allows you, like we said before, very good roughing properties, very good wall finish, a decent floor finish, but it does not have the wiper flat, and that's where the 4-in-1 series comes in. The 4-in-1 is our latest series of single flute end mills. Of course, it is a single flute. It actually has a more sophisticated balancing process at the factory, so these are balanced to a finer degree than even the balanced series. So even less vibration. They do have the wiper flat built in, and those are available in a torque cut as well. So these guys will give you excellent roughing properties, very, very excellent wall finish, and an excellent floor finish as well. So moving on from here, we want to talk a little bit about what materials you can cut with single flutes, why those materials work well, and what machines do single flutes work well in and under what circumstances. So to answer the question of what materials work well, we actually pulled this chart here. Gotta love charts and graphs. We pulled this chart here from an excellent white paper called The History of High-Speed Cutting. It's by a professor at the University of Darmstadt in Germany, and that will be available in the follow-up email to everybody watching the webinar today. But what you see over here on your y-axis is cutting temperature, all right, from low at the bottom to high at the top. And then over here on your x-axis, you have cutting speed, low on the left, high on the right. And what you see here for materials like aluminum, for example, you can see that the cutting temperature actually goes down as the cutting speed goes up. Same is true for bronze. Engineered plastics would exist in this area here as well. And this property of material for the cutting temperature to go down as the cutting speed goes up is at the very core of what makes high-speed cutting possible. High-speed cutting leverages this property of materials to allow you to be much more efficient in your milling process. So what that translates to in actual materials, Dan can go over with you here.
Yep, so no big surprises here. A lot of your non-ferrous materials, aluminum, brass, copper. Now there's some that we don't mention here that I personally use single flutes on that work quite well, one of them being like copper chromium, which was pretty tough, and we had a customer that was dealing with a lot of burrs in that material, and it actually worked wonders on it for their particular application. As well as some plastics, glass-embedded fiber plastics, things like that, where single flutes actually work fairly well too. It's just important at that point to have a good coating on the tool, like the Alcrono coating that we offer. Even some of the 3000 series aluminums, which are pretty soft and gummy, we've had some customers with good success in milling those. So as well as just normal copper, which usually most people hate to cut. It's too soft. Because our tools are so sharp and are so good with chip evacuation, they do a pretty bang-up job with tough materials like copper.
So to touch on the compatible machines real quickly, we've found some very good success with a number of cutting tool customers that use them in compact, entry-level, desktop milling machines, right? So these are machines that have a light-duty spindle. They might have a high RPM range, up into the 20,000, 25,000 RPM range, but they have low power, low torque, and they have no flood coolant. So as a result, you don't have the ability to have the flood coolant get the chips out of there. So you can rely on this one, single flute cutter to evacuate those chips, clear them away from the cutting process, and allow you to get some very good performance from these light-duty compact machines.
Yeah, like good examples would be the Other Mill Pro or the Pocket NC, the 5-axis mill. But we've also had some people, I think, with maybe X-Carve use them on DeWalt routers for their spindles, and you can even see benefits there.
Next machine up that we want to talk a little bit about would be just kind of your typical, BMC, your vertical machining center, your horizontal machining center. If you have a traditional, workhorse, Haas, Mazak, certainly a Robo Drill, Fadal, anything that has an RPM range that extends up into 12,000 to 18,000 RPM, you'll be able to get some benefits from these single flute cutting tools in certain situations. And we're going to go through exactly what situations those are, where single flutes actually outperform a multi-flute tool, even in a traditional BMC. And then, of course, it kind of goes without saying that for high-speed machining centers, such as a Datron, a Kern, a Micron, a DMG, anything that has, an HSK, 32, an HSK 25, anything that has an RPM range that goes up to or beyond 30,000 RPM, you're going to be able to get a lot of performance out of single flute end mills.
Absolutely.
So at this point, we're going to go on to our applications examples real quick. And one thing I actually want to mention that marketing would be angry with me if I didn't mention at this point would be the follow-up email to this webinar. Anybody who is attending today will receive a coupon code for 25% off one order of Datron cutting tools. And again, we have them in stock at East and West Coast locations, so be sure to keep an eye out for that and take us up on the offer. Why not? So the material removal rate study, Dan, maybe kind of walk them through what we did here.
Absolutely. So what we wanted to do is, obviously, if we just showed you us cutting this part at all Datron feeds and speeds, it would be like a no-brainer. Of course, they work great. We wanted to show instead what it would look like if we cut it at maybe the top of your Haas's range, right? So you might have 15,000 RPM on your Haas or your Tormach or your benchtop mill, something along those lines. So we wanted to represent, can you use them at low RPM? So we wanted to do a little bit of a study to show, are there benefits with our tools, and give you some examples. So first, we're starting off with a 6mm single flute compared to a name brand 2-flute mill doing a slotting cut.
Right, so this is a 100% width of cut,
yep.
And we relied on the manufacturer's recommended depth of cut and chip load, all right? So we used our own recommended values for those, and we used the other tool manufacturer's values for those as well to try to keep it even.
Yep. So we can see here that the depth of cut on our tool, 57 thou, as compared to the 2-flute, 81 thou. So we're at a little bit of a disadvantage there, but the chip load is significantly higher on ours. It's actually about double what the 2-flute is recommending. So ultimately, we end up with a faster feed rate, 94.5 inches a minute versus 82. And if we go over and take a look at what the MRR, the material removal rate, will end up being in cubic inches per minute, we get 1.23 versus 1.58 for the double flute tool. So a slight disadvantage. You can see here where it becomes super desirable if you have 30,000 RPM, like on a Datron. We're actually about a cubic inch more than the 2-flute at 15,000 RPM. And that's actually on the low side of what we would run that tool at. It would be about 35,000 RPM.
And what's interesting here, as we move on, we're going to go down in terms of diameter to a 3mm, which is roughly an 1/8 inch cutting diameter. And what's interesting here is you're going to see that these values end up getting switched, flipped completely, right? Yep. So again, depth of cut, we're actually taking a slightly less depth of cut.
We're getting closer to each other. 49 thou versus 59 thou with the 2-flute. And then we have the chip load. This is significantly higher, 5 thou 3/10 as compared to 1 thou 5/10 chip load with the 2-flute from a competitor's tool. And then we can see that translates to our feed rate, 76.5 inches a minute versus 45. This is what's recommended for slotting again. And if we look at the material removal rate, we can see here we actually outperform the 2-flute at 15,000 RPM, 0.42 versus 0.314. And then you can see with the single flute at 30,000 RPM, which is, again, on the low side, we'd run this at like 38,000 RPM roughly, totally trounces the 2-flute, 2.5 times greater material removal rate at 30,000 RPM.
And really, if you just think back to what we talked about a few minutes ago about the ability to create a larger chip and evacuate it very, very efficiently, that is the reason why we see this outperformance right here. So it's certainly a valuable tool in some situations, even at 15,000 RPM. Just to drive it home here, we went down to a 1.5mm cutter, roughly 60 thou.
Yeah. So we're actually deeper with our depth of cut, 28 thou, nearly 30, versus 20 thou from the 2-flute. And then chip load, 4 times greater, 2 thou, 4/10. These are just what was recommended by both manufacturers of the tools, Datron and we'll call them Marby tools, something like that. Yeah. 2-flute, 6/10 chip load, pretty small. And subsequently, our inch per minute feed rate is doubled, 36 inches per minute versus 18. If we look at the MRR results, we really blow it out of the water, about 2.5 times greater, just at 15,000 RPM, and then significantly more than that, about 5 times higher cubic inch per minute material removal rate at 30,000 RPM.
So you can see even at typical BMC RPM ranges, there's a place for these tools in the toolbox, and there's a spot in a lot of parts out there that have a small inside radius. For whatever reason, you need to get a small tool down into a deeper pocket, and you might have an issue with recutting chips or clogging up those chip channels. A single flute tool can probably be your salvation in that situation.
Absolutely.
So at this point, we're going to switch over to some live demonstrations. We've got an M8 cube here with a 40,000 RPM HSK E25 spindle. So I recommend you go to a full screen view of our live video feed. We're going to have information here on the presentation just kind of outlining the milling specifications that we'll be running. So you can always check back here to see exactly what Dan's doing. But Dan, I'll let you take it away. Let's make some chips, man.
Cool. So we're going to start off with slotting, which is what most people think of when they think of single flutes. Why use a single flute? Well, it's good for routing, right? So we're going to show that off because it's sort of a given. So this is using one of our 4-in-1 6mm tools, wiper flat end mill. At the recommended depth of cut, 2 millimeters. We're going total of 6 millimeters deep. This is just a reminder, at 15,000 RPM, we're going 94.5 inches per minute.
You see excellent chip formation, excellent chip evacuation, spitting a rooster kill of chips out the back end there.
Now, just for comparison, we're running it at Datron's recommended RPM, which is 35,000 RPM by comparison, so we're going to go significantly faster. 220 inches a minute. Same 6-thou chip load.
As you can see, no problem with chip evacuation, no problem with chip welding. And really, at this RPM, we're taking full advantage of that property of aluminum for the cutting temperature to go down.
Exactly.
So we're really in the high-speed cutting range at this point.
Now we're going to move on to entry angles. Everybody wants to know, once they start with a new tool, how can I feed this thing in? I don't want to jam it up with chips right away. So what's my best entry angle? Well, let's go over a few. So we're going to start with 5 degrees. Pretty conservative. Okay? Let's see if we can go more aggressive. How about 15 degrees? Well, that seems just fine as well. So let's switch it up and do 25 degrees. All right, this is boring. I'm going to just do a 90 degree. How about that?
So even just plunging straight into the material, this tool is forgiving enough to be able to evacuate those chips out of there.
That's what I was going to add. Is that's one of my favorite features of the single flute tool. Especially, I'm thinking of like if you're a Tormach user, where this is, tools are expensive and you don't have to waste money on them because they clog up with chips. With single flutes, they can be pretty forgiving even at lower RPMs. So now we're going to do all the same at 35,000 RPM.
And again, this is for some of those high-speed mill users out there, the micron users, the DMG users. This is the type of performance you can expect in those machines, or of course in a Datron, anything that has that type of RPM range. And while we're going through this, everybody, if you have any questions, anything that you're not sure about what we're saying here, feel free to send them in on the Q&A chat line. We'll get to those as we're going through these demonstrations because, above all, we want to make sure that we get all of your questions answered here.
Yep. Moving on, we're going to switch to do some adaptive clearing / dynamic milling, whatever the cam software you have. You probably have it, that full depth tricoidal sort of pocketing maneuver. So we're using a 3 millimeter single flute here, that's roughly an 1/8 inch. And we're using it at the recommendation of Datron 3.5 thou chip load per tooth, which is 1, so that's easy math to do. We're taking a 3 millimeter depth of cut with a 15% step over.
Just getting a question over here on the Q&A board. Are these tools available in the UK? Absolutely. You can reach out to our Datron partner in the UK. It's Datron Technology. We'll see if we can provide a link to that on the follow-up email here.
So no problem here, obviously, taking care of these pockets. One of the next pockets we have coming up is the more traditional, I call it dumb pocketing as compared to this, which is smart pocketing.
Right.
Which kind of shows off where you would have some benefits if you're doing shallow features where you need a bigger step over.
And again, for anybody joining us right now, this is happening at 15,000 RPM.
53 inches a minute.
Yep. Kind of just sort of showing off what's possible with single flutes in traditional machining centers.
Now, sort of the downfall of these tricoidal milling tool paths, adaptive clearing, is that when it comes to doing a slot, so we're doing a 125 wide slot here with a 118 wide tool, so it ends up taking a while. It just sort of nibbles away at that slot until it's all gone, and that's an okay way of doing it. But that's sort of where it becomes advantageous to use a single flute, is to take this in those sort of more traditional depth passes. You're able to just basically plow right through this slot and not have to worry about pecking away at it. So if it's eating at your cycle time, it might make sense to do a more traditional style pocketing maneuver.
And in a moment, we're going to switch over from the 15,000 RPM test to a full 38,000 RPM test, and we'll be able to see the difference in your feed rate there while still maintaining a good chip evacuation.
Yep, so this is at 38,000 RPM, going 133 inches per minute. See, a little bit more zippy.
Slight difference there, just a little bit. Now, while we're doing this, I just want to talk a little bit about some of the follow-up stuff we'll have available to anybody attending the webinar today. You're going to get an email from us with a couple of links. One is going to be to that white paper that we referenced earlier, The History of High-Speed Cutting. Very good, very technical read, and really spells out how high-speed cutting came about and some of the advantages of it. We're also going to send a link off to a post by CNC Cookbook, which is an excellent resource for any machinist, and it's a post that's all about why to use single flute end mills, which is certainly a good complementary piece to what we're doing today.
Yep.
So we got a great question here from somebody in attendance today, talking about the recommended cutting speed for Datron tools is 50 to 730 meters per minute. But the graph that we showed earlier from that History of High-Speed Cutting white paper showed a much higher desirable feed rate, roughly 600 meters per minute. And his question is, what am I missing? Well, there's always going to be some difference between the ideal cutting, in a sort of academic realm compared to the in-practice cutting, right? So all of the feed and speed parameters that Datron publishes have been tested by our technology team in Datron, Germany, and have been determined to be the best mix of, being aggressive to have a good cycle time without pushing the tool too hard, limiting your tool life, things of that nature.
It's worth stating that if we had infinite RPM, that actually, I remember hearing from Marv Grove from Datron AG, that sort of all forces from cutting all sorts of materials would basically vanish. You would have no tool wear.
Right.
So, but we don't have infinite RPM to play with. Unfortunately, we're all limited. Even Datron, we only have 60K.
For now.
For now. So
we're working on that infinity spindle.
Right.
Right.
So,
that's coming out soon.
And as your tool diameter gets smaller, then your cutting speed diminishes. So it's making the most with what you have, basically.
Yeah. Another good question here coming from the audience. Are you using any compressed air for evacuation?
So we're actually using an MQL system from Microjet out of Germany, and it uses a mixture of air and ethanol. So what that gives us is an evaporative coolant system that works really well for leaving no residue on the chips and no cleanup from flood coolant, and giving us really excellent tool life and surface finish.
Yeah, that's a method for cooling that we've been using for decades now. Does a phenomenally good job as the ethanol phase transitions from liquid to gas, sucks all the heat out of that cut, and like Dan said, gives you better cutting tool life, and just better performance overall.
Just to point it out here, we're doing some of that traditional pocketing, and you can see that one slot that we were dealing with before that we used to have to peck away at. We're running right down the channel at a millimeter depth of cut and taking care of it. There's all the information for that up on screen. We have a question from Smaller. Can you talk about the new large single flute base mills? We have yet to get them in our inventory, but I am hoping to do some sort of webinar presentation on that in the future. Basically, we now offer them in larger sizes, I believe 14 and 20 millimeter, actually up to 24 millimeter if you have a more powerful spindle. And we're really interested in using those in some upcoming applications.
Yeah, a comment from the peanut gallery here, our friend Eddie Kramer. The coolant is good at parties too. It is denatured ethanol, Eddie. Don't forget about that.
Yeah.
Denatured.
I was talking about mixing it into my coffee. It would be like an Irish coffee, except it would be German.
German coffee.
Now we're just taking a finishing pass on the walls. Yes, they are. So we just got a question from
It's from a customer of ours down in Massachusetts. He's using an M8, and yeah,
we have a new catalog that came out recently and a follow-up feed and speed booklet that goes with it. So that should be available for anyone that's attending this webinar. You're going to get an email afterwards with a link to download that.
Yep. So moving on now, I think we're getting on to the fun stuff, right?
Yeah, well, not quite yet. We're switching it up to well, I would consider this fun. This is fun.
Sorry.
This was actually a request from one of our application guys here, Kevin, who really loves this tool. He came from traditional machining world and always struggled with these small sizes. We're using 1.5 millimeter single flute here, and we're doing all these interpolating moves or ramping moves. Some of these are helical bores, some of them are pockets. And it does remarkably well. I was surprised, even with 15,000 RPM, it handles it very, very well. But he said, and a lot of our customers have said about their single flute tools, they're kind of hard to break. You have to push them extra hard and do something stupid if you really want to annihilate them.
Yeah.
So even with small sizes, this is only 59 thousandths of an inch, we're taking care of these small features quickly. We're bringing it down to 6 millimeters depth. That's 4 times diameter. At 15,000 RPM, taking it between 10 and 20 inches a minute. So it's doing a pretty impressive job, all things considered.
Yeah.
And it all comes down really to that chip evacuation issue, because as your tool gets smaller, there's less room to create a chip channel. So you end up with chip weld issues even more in small diameters.
Yeah, which is really where these tools can shine, even in like we said earlier, even in a typical BMC. And you're absolutely right. I mean, we have customers that use these cutting tools in Haas machines, where they have, plenty of torque, plenty of horsepower, and they push them hard. They push them really hard, and they have yet to be able to break them. So that just is a testament to the quality of carbide that we use.
Yep.
Very low carbon content. Any pockets of carbon inside carbide is just going to give you a potential failure point. So limiting that gives you much more strength in the tool.
So we're taking care of some of these small features here. The slot is only about 80 thousandths of an inch wide with a roughly 60 thousandths inch diameter cutter. Taking care of it, no problem. We're going to move on after this to same tool at Datron recommended RPM, 39,000 RPM. And we're going to bump up basically triple our feed rate at that point, 29 to 50 inches a minute.
Not too bad.
Not too bad.
So again, anybody joining us today, you're going to get a follow-up email from us with recommended feeds and speeds, some white papers that you can read, and of course a coupon code good for 25% off one order from Datron for any of the cutting tools that we have here. So we got them in stock, East Coast and West Coast. If you have any curiosity about these tools, give them a try. We'll be happy to give you some pointers on how to run them in whatever machine you might have, and I think you might see some success with them.
So this tool we're using is actually one of our standard single flute end mills. As compared to the last two we use are some of our 4-in-1 tools. And it's worth note that the last two I use are like kind of personal favorites. They're the short length. They end with A, which means that they are basically sort of square geometry, like the 3 millimeters 3x5, the 6 6x7. And then coming up, we might have a 10 millimeter tool that's 10x11. They're very, they're kind of stumpy, but they're excellent for roughing.
Yeah.
Very robust.
Another question here from one of our viewers. Can you comment on plastics that generate very stringy chips and wrap around the spindle or tool?
Absolutely. My recommendation typically is to either turn your feed up or turn your RPM down, because you need to make a little bit more of a heavy chip. Otherwise, you just end up imparting heat into the material, and that's what gives you that stringy result where it kicks up burrs and things like that, because you need to be a little bit more aggressive to really shear the material cleanly. And get it out of there.
Another question here from the audience. How can you tell when your tool is getting worn? Typical lifetime. Good question. Good question, Dan. What do you think about that?
Well, signs that it's getting worn. Obviously, once you start seeing streaking or something like that in your wall finish, it might be time to retire that tool as a rougher and use a different one as a finisher potentially. But a lot of customers we have just end up using one tool for roughing and finishing operations. But generally with ours, they'll get a cratered edge or something like that, and that's sort of game over. Just want to move on before I keep going with this. We're just going to do a little bit of gratuitous roughing here. just because we can. This is both ways adaptive clearing, which is coming to Fusion 360 shortly, I believe.
Yep.
So we wanted to show off a little bit of that here with our 10 millimeter single flute. This is a 4-in-1 tool, and it's one of those stubby A lengths. Pretty aggressive, 15% step over. That's a 1.5 millimeter step over, 15,000 RPM at 106.3 inches a minute. And this is just fun to watch.
Yeah, you can see just excellent chip formation, excellent chip evacuation, just clearing them right out of there. A lot of people, when they first see this, what is called dry machining, we are using a coolant here, but they don't understand, how do you manage the chips? Well, the geometry of the tool is really what evacuates the chips. It gets them out of there so you're not recutting them. They don't interfere with the milling process moving forward. We really rely on the geometry of the tool to get the chips out of there, more so than with typical 2 or 3 flutes. So a couple of other questions we have here on the question line. What are the coatings? Coatings available in single flutes. Which ones do we offer and why, Dan?
We offer the Alcrona coating, which is ALCRN, aluminum chromium nitride, and that's pretty much my top recommendation. We also offer, but not for single flute, Exceed coating, which is ALTIN, a bit more common in the industry. I'm partial to Alcrona myself, though. Let's see. In the demo, all of the cutters are uncoated. That is correct.
Yep. Yeah, we actually prefer to use uncoated cutters whenever we can because the coating actually slightly dulls or rounds over that cutting edge.
Yep.
So you have actually a much sharper cutting edge with an uncoated tool. So unless you are not using coolant at all or unless you have a highly abrasive material, our recommendation is to always go with an uncoated tool.
Yep. And just before we answer any more questions, we're doing that same 10 millimeter tool, except now at 32,000 RPM versus 15. I'll answer questions after. This is just fun to watch.
Yes, here we go. Make that material go away. Get it out of there. Questions that we have coming through on the question line here. One, do you have a serrated single flute bit available to help with chip clearing in plastics? And I think that the short answer to that is no. The longer answer is that in our experience, it's really not needed. The serrations in end mills typically exist to try to break chips up because they're getting in the way.
Right.
And the single flute, that single large flute, is so effective at clearing the chips away from the milling process that it's not necessary to have a serrated edge to clear or break the chips. It's just fortunately not needed.
Yeah, I agree with that. You could see there, even at 15K, that most of these tools are doing a pretty good job at tossing the chip out of the way. So chip clearing isn't so much of an issue for single flute tools, at least in our experience.
Yeah.
Question about the spindle load. Is spindle load too high? What would the maximum saved current show on screen? So what we were running here is a 3 kilowatt spindle. That's about 4 horsepower. Yeah. Running it at a low RPM. And they're not real torquey. That's just sort of the way our spindles are. It's high RPM, lower torque output. And I wasn't peaking the load on any of the cuts that I was doing here. It was all pretty moderate. I'd have to say it wasn't really exceeding 50% at any time.
So a pretty safe load on that spindle.
Yep.
So we've got a fairly specific question here. We've got a webinar attendee who's using a Vision 2450 engraver router, which is a great solution for light-duty engraving. Been using single flutes for 5 years now. Typical material is aluminum. And this guy's running 10 to 12,000 RPM on a 3/32 inch bit, but he does not go above ½ an inch per second feed before the bit breaks. What do you think about that, Dan?
So 10 to 12K. I'd be curious, and maybe you can talk about this, Chris. Are you using coolant? And I'm a little curious about, let's see,
what is your max RPM?
Yeah, what's your max RPM?
Initially, I would say use more RPM on that tool, and you'd probably have a pretty good result.
Now, just and that's not a real small tool, 93 thou. That's a little bit smaller than 3 millimeter.
What would we typically run that tool at?
Well, with that size, we'd probably be running that around a 4 thou chip load, something around those, maybe 3 to 4 thou. So at 30,000 RPM, you'd be looking around 100 inches a minute.
So yeah, I mean, Chris, it's one of those situations where sometimes you just got to crank it up to get better performance. And I think in your case, if you have more RPM that you can throw at it, I would encourage you to use more RPM, and that will probably allow you to go faster in terms of feed rate without breaking it, right?
Yeah, right.
So let's see. So as we're wrapping up here, we're gonna go through. Oh yeah. So Chris, yep, I'm using coolant. I have 20,000 RPM to play with.
Yeah, I would say I would probably recommend one of our tools first to try.
Hey, 25% off. That doesn't hurt.
And then based on that, we can give you some good numbers for feed and speed with that. But if you're using coolant, then you should be in good shape. So I'm not sure exactly what the issue is there. I'd be curious. You could reach out to us and we can try to help you out a little bit.
Well, along those lines, additional resources that we just want to let everybody know about. Again, the follow-up email to this webinar will include a link to the History of High-Speed Machining paper. It'll give you some links to our Datron.com blog, where you can get blog posts from myself, from Dan, from a lot of our other application engineers here, all about everything from single flutes to setup sheets and everything in between. You'll also get a link to why use the single flute end mill, again, from Bob Garfield over at CNC Cookbook. And if you want to reach out to us at all with a request for quote, with a question on how to run these tools, tools@datron.com is the best way to get in touch with us.
Had another question there.
I think we did. Hold on a second. Let's just pull that up real quick here.
Acrylic material tends to melt at high speed. Yeah, if you run your RPM too high, you're going to run into that issue unless you're feeding it in really aggressively. So typically, I back off on my RPM a little bit. So if I would typically run, say, a 6 millimeter tool at 35,000 RPM in aluminum, I would run that somewhere around maybe 25 to 28,000 RPM in acrylic, somewhere in that range, just to take a more aggressive chip.
So that is just about it. We're certainly over time here, so if everybody's got to get back to work, we certainly understand. We'll go ahead and continue answering some questions here from the audience. How do these knives, he's referring to as cutters, yeah, how do these cutters handle fiberglass?
I think we've used, or G10, it says here, so we've used them in G10 before. I think it was actually one of the ball mill variants of this. We offer the tool, besides normal square cut end mills, we have them as well as ball end mills, and not left-hand cutting, but down cutting end mills for small materials on vacuum table, as well as there's one other variant I forgot to mention. Oh, it was the large face mills, which we had talked about earlier. And they worked fairly well. The one thing you want to look out for is just because of the abrasive nature of fiberglass or G10, you'd want to use it with a coating to help lengthen the life on it a bit.
Yeah. A couple other good questions here. Have these end mills been tested out on coated aluminum, on anodized aluminum, which is something, especially hard anodizing, that can really ruin your day?
Yep.
We've seen it quite a bit. I know, Dan, you've cut some hard anodized parts, right?
Yeah, so if you're doing really shallow milling, it can be a bit of an issue because you're concentrating all the tool wear right at the tip where it's the hardest. If you can dig into it a little bit and sort of, create your chip starting from the bottom below that hard anodizing, that certainly helps. Sort of, inevitably you're going to wear a groove into the flute right where that anodized coating is. Yeah. But you can work around it to some extent.
Got a question here, again, on some glass-filled engineered composites. So 40 to 50% glass-filled poly. How would these tools hand up? I would certainly say use an Alcrona-coated tool. But aside from that, are single flutes the best tool in that type of material?
It's tough. That's pretty glass-filled. Yes, so I might, depending on how rough it is, how abrasive it is, I'd say you could be better off with, we offer some other tools commonly referred to as like fishtail cutters that are like
serrated 4 flutes. Those have exceed coating or diamond coating. Those sometimes are better for the really heavily glass embedded plastics.
Yeah, or carbon fiber, stuff of that nature. So again, there'll be a link to our tooling catalog in the follow-up email. Follow that to check out those fishtail cutters, and those work quite well in high fill.
Yeah, we should have a copy of the catalog or a link or something like that in the email going out after this.
Yep.
Just to specify the coolant setup again, that was a microjet system out of Germany on our M8 Cube here, 4-nozzle microjet system blowing a MQL style ethanol. So evaporative coolant system.
Yeah, and if you can't, I'm not sure if Microjet has representation in the U.S. If you want to retrofit that type of minimum quantity lubrication system onto a CNC machine, Unist is a great company for that type of hardware, and I know that they have local representation here in the U.S.
Yep. We have a question from Simone asking about feeds and speeds for acrylic. You have 15,000 RPM to play with. What would our recommendations be? Off the top of my head, I'm probably going to have to say all 15K, maybe 40 to 60 inches a minute. That's just sort of shooting from the hip. What we can do is if you reach out to us and ask us for some advice through that email, tools@datron.com, as long as it can reach my way, I'll be keeping an eye out for it. We can send you some of our recommendations for feeds and speeds for our acrylic lineup of cutting tools, which are usually pretty helpful for that.
Yeah, but again, at 1.5 millimeter acrylic, the single flute will work very, very well.
Yep.
And again, that line specifically for acrylics and Lexans was the first to use that polished cutting edge and the polished flute, just to give you even better cutting in that type of material specifically.
Yep.
So let's see here. Can you speak to the advantages of the standard polished single flute versus the foreign ones? Yeah, I mean that's.
I would say in terms of advantages, I would say in that 3 millimeter and under, that's all that's available. You can't get 4-in-1 lower than 3 because there's no real need for balancing at that point.
Right.
So at that point, it's tough. The 4-in-1 is just a really great adaptation, evolution of the tool from the standard series. They're just a good all-rounder. If you don't have high RPM to play with, you might save a little bit of cost in terms of the cost of the tool, being able to run that. And since it's not polished, it might be fine for just doing some general roughing work. So it's a totally fine tool, and I still use them on a pretty daily basis. It's just there's some instances where I prefer the proportions of a 4-in-1 as well. Like all those A variants are so short and stubby that they do an outstanding job with roughing.
Yeah, but I mean, my take on it would be that, if you're, the standard polished single flute versus the 4-in-1, it really comes down to what's important about the part, right? If you need to be very aggressive with the milling to get a high material removal rate, the 4-in-1 is going to do better in that area. If you need a better floor finish, the 4-in-1 is going to do better in that area. If you're just doing general milling of acrylic and you want a very good wall finish, but you don't need to be super aggressive or anything like that, the standard polished single flute line will do you just fine.
Just want to add, there's going to be a survey that goes out after the completion of this webinar. Please fill it out. We would love to do more of these. We just want your feedback on what you want to hear. What did we miss on in this presentation? Where can we better educate and entertain people?
Yeah, absolutely. We tried to make this fun as well as educational. So hopefully it was that for everybody there. Aside from that, keep an eye out for more of these webinars. Find us on Datron.com. Find us on Instagram. And, of course, hopefully we'll see everybody at IMTS in the fall.
Oh, we have one other. Do we do a lot of slotting in brass?
Okay.
Is it better for this tool to do standard slotting in tricoidal? 5 millimeter, I would slot it. It depends on what you have for RPM in part. Slotting is just, it does it so well that I would probably just go with that, doing it if I could. If I didn't have a lot of RPM to play with, like let's say I was really limited, maybe only 5,000, then you can anticipate that it might not throw the chip that well. So you might want to switch to tricoidal. But if you could use an air blast or something like that, I would say that you're probably pretty safe
just doing straight slotting maneuver. A few more questions. I have seen some of Datron's videos on YouTube. Nozzle of the MQL system is changing according to the cutting direction. Is that programmed or built-in feature of the microjet? So that is actually a feature of the previous generation style coolant system that was made by Datron, and it was Venturi-based. It would siphon it through a feed line and spray it out of the left or right side. And that was sort of an effort to consume less because it brought us to consume quite a bit more than the microjet system does. The microjet system is a pressurized vessel, so you regulate how much pressure is being applied to the fluid, and that regulates the flow of it. And it has 4 nozzles that are either fixed or adjustable, and that's what sprays onto the tool. I'd prefer microjet much more. It uses less coolant overall, just more efficiently.
Yeah, certainly. And it's, minimum quantity lubrication it's one of those counterintuitive things that, using less fluid actually works better. So the newer microjet system doesn't turn on and off depending on direction. That's actually an outdated system that you won't see too much more moving forward. I think that's about it. All right, well, hey, everybody, thank you so much for joining us. Oh, wait a minute. No, we've got a... Nope, Radu's coming back with another question here. What is a good balance of pressure adjustment on the microjet? How many bars for liquid and how many bars for air?
There's actually a recommendation in this feed and speed guide that we'll be releasing after the conclusion of the webinar. For like this demonstration, I was running around 2 to 3 bars for pressure on the tank as well as the air, the atomizing air supply.
Perfect. All right, coming up on 1 hour here, guys. Thank everybody for joining us.
Thank you for the compliments.
We had a great time. We'll do it again. I believe we have our next webinar scheduled in June. That's going to be on work holding, so we're looking forward to doing that. And thanks for everybody for joining us. Feel free to reach out to us on tools@datron.com or on Instagram if you got any questions. We're here to help.
Reach us through Instagram, Facebook, as well as fill out that survey afterwards and let us know how we did. Thank you, guys.